Good afternoon, everybody, and thank you for organizing such a great event. A special thanks to Peter Fusaro. I would like to start with a concept that maybe...
Jack, if I may real quick, I just want to remind everybody that, and apologies for interrupting, but please do ask your questions. If you're just joining us, ask your questions right in the Q&A box, and I will get to them in approximately 10 minutes. My apologies, Jack, please.
Yeah, not a problem. So basically, pursuit for efficiency does not always translate into effectiveness, because most of the solutions, what we found, are kind of manufacturer driven, and a highly engineered solution that can connect buildings with nature is seemed to be having trouble finding its way to the mainstream. What's happening is, if let's say we use concrete as a not only just as a passive asset in a building, but we can convert it easily to a smart asset. And how could that happen? If we connect a thermostat to a concrete floor, or specifically to a ventilated floor, all of a sudden becomes a smart asset that can store thermal energy year-round. So it means it can store energy in the winter and the summer. And the need for mechanical equipment is considerably reduced. So so the tools and templates that conventional engineers have, and assessment tools, they find it difficult to see the buildings from a different perspective, where the building can become a thermal battery. And in fact, lately, the research confirms that the thermal energy storage in the buildings could be more important than the battery storage. Because the need for thermal energy, it means heating or cooling, is much greater than for any other needs. So what we found that the buildings that have the thermal energy capability, which could be any building, they basically become smart city enabled, and it means they are energy grid interactive. So buildings all of a sudden can share energy between each other. So it's not only about one building, but it's about how these buildings can fit into smart city energy management grid. And what's even more interesting, that the need and capacity for indoor comfort systems can be reduced considerably. It can range from 40 to 50%. So what it means is that not only from a financial point of view becomes a more bankable building, but people can use more energy and pay less. So anybody that, let's say, would like to add solar, all of a sudden they may find that 25 or 30% less of installed solar can do the same job a lot better. When we're talking about nature-connected buildings, they have been tested in Canada, United States, and India. And what's interesting is they all have one thing in common: they perform very well. Canadian buildings, for example, educational buildings in particular, have been validated against 6,000 educational buildings, and they have been rated best performing. The reason being is, again, we can harness low-grade energy that today 100% mechanically driven systems cannot pick up the free energy that surrounds us. And one such example, for example, in educational buildings, is that schools in Canada, in a colder climate, in the winter, they're predominantly heated with the body heat of the students. So the only time when the heating is required is when the students are not there on a long weekend or holidays. And that is validated by utility meters. So what is interesting, it's really applicable to many applications. It could be horizontal housing, it could be institutional buildings, medical buildings, They could be any kind of building that basically people occupy and they need climate control. These buildings, as a rule, can use about 40 to 48% less of a carbon footprint compared to other conventional buildings, other high-performance buildings, sorry, that cost a lot more money to build. So the buy-in from the public definitely could be much greater because there is no particular burden to end up with a better building that doesn't cost more. What's interesting in residential buildings, the wellness package is noticeably missing. By engaging the ventilated concrete floor, it basically delivers radiant comfort. And that ties into wellness, that can afford fresher indoors, a better good night's sleep, and built-in resilience. So given that when we combine all of that together, then we basically end up with the decision makers making better decisions. And from financing point of view, it becomes a better bankable building because it costs less to build a better building. So stress test for net zero buildings obviously dials back to one thing. They cost more. And that's why one form or the other of financing or incentives or tax breaks is needed to move the needle in the right direction. So increasing the efficiency, energy efficiency, indoor air wellness, and especially with COVID, ventilation safety, and in places like Florida, resilience to extreme weather conditions, can be fairly straightforward. And the buildings themselves that have the concrete floors, they can become intelligent buildings that have a direct handshake with the smart city energy grid and energy infrastructure. It's not only about one building, it's about looking at buildings from a larger perspective and ending up with much better outcomes. So this solution has been tested and proven for more than 15 years, and it makes a lot of business sense. So decarbonizing buildings using concrete as a smart asset fills the gap that is noticeably missing. And it's not only to build a building cost less, it just makes a lot more sense, and it cuts embodied and operational carbon. So because we need a lot less equipment, a lot less mechanical equipment, a lot less mechanical moving parts, and a lot less solar to offset, to create a carbon neutral building. That's one part. The other part is the operational carbon. It was actually quite interesting that it was noted that the buildings, 2/3 of the energy they consume after they build, or the carbon footprint is there. Since our building energy use intensity in the building is much lower, and I would say 48% on average, compared to, say, conventional buildings, let alone higher cost buildings. So it just makes a lot more business sense, reduces the risk of financing, and kind of dials into kind of a 3L approach: low cost, low risk, and low carbon edge that can be achieved by using conventional technology that we have today. So any other technologies in the future that will become a lot more efficient, I guess when it comes time to replace them, they would make a natural handshake. So the concrete by itself is acting as a smart asset connected to a dashboard that has all the metrics. It measures in real time energy, carbon, the kind of pollution, any metrics that we basically would like to measure, how much solar we used, how much wind we used, or anything else, it's all there. So technically, it can carry out instant energy audit without cost and complexity. In a nutshell, it actually makes buildings, since the buildings are a lot simpler, then to maintain them becomes a lot simpler as well. And if the maintenance is simpler, because many of the buildings, no matter, especially the more sophisticated ones, the maintenance people are not that sophisticated and they keep moving around. So buildings may end up in a simple mode, operating in a simple mode, break, fix. So if somebody says it's too hot, too cold, no problem, we'll address it. So I guess I kind of reached the point for questions and answers, or I guess I can continue.
Yeah. Jack, thanks very much. We do have some questions rolling in.
I can't hear you.
Oh, can you hear? Okay.
Yeah, now I do.
Good. So we do have some questions rolling in, so maybe we'll start with them, and if we have a little extra time, we can always do that as well. First question comes from Stephen, and I have a similar question. Can you help us visualize a little bit more clearly how the system works? I don't know if you have a cross section or a diagram you might be able to show us, or if not, just walk us through a little bit more of the nuts and bolts.
Okay. I do have it, but I have to pull it up. I didn't expect that question. I did expect the question, but since the request was more for kind of a talking show or a talking presentation.
Jump that upon you.
Yeah, you see, one of the products that we are using, let me see if I can find a quick diagram for you. One of the products that we are using are precast hollow core planks. The precast planks, they have round 6-inch diameter holes in them that span from one end of the plank to the other. So we can use these voids as a branch ductwork, and we create a labyrinth. In fact, we create above ground geothermal labyrinth. So that in terms of the length itself, it can reach, depending on the building type and the loads, it can be between 85 to 100% of the geothermal loop in the ground. So it means if somebody likes geothermal, we need half of the geothermal in the ground. That will do the same job a lot better. So the cost and payback of more sophisticated systems that make a lot of sense, all of a sudden, they basically they become a lot more efficient. Let me see if I can.
We can jump to the next question while you're looking for that, if that's okay, yeah. Just to keep it moving. Concerning the rough payback for this kind of thing, at what point would residents or building owners see a cost saving? Let's say an example, 100-unit building. Okay,
so in residential buildings, obviously compared to institutional buildings, it's a slightly different scenario. So, and again, it all depends on the builders or developers' intent on what kind of systems they want to put in. You see, the building comes with built-in radiant comfort. It means it has built-in radiant heating, radiant cooling, thermal energy storage, and enhanced ventilation. So the wellness package doesn't cost any money to do it because we engage the concrete. So it's the value add engineering that basically comes as a result of the preferences for the choice of equipment. Could cost the developer maybe 1% more, but they can charge about 5% more for the wellness package that is built in there. So we looked at a building, for example, in Fort Lauderdale, where the developers were looking at 25% return on investment. our wellness package commanded 32.8% return on investment. So we shifted from 25 to 32.8%. In institutional buildings like schools, colleges, universities, it costs less to build a better building. Well, I'll give you an example. And again, it depends on the design brief and the intent of the type of equipment they want to use and the building fabric they're using in windows. But they can save from $15 to $50 a square foot capital cost to build. Now, the maintenance and operating costs, if we're talking, for example, about public-private partnerships, they basically, if somebody develops a hospital that costs $1 billion to develop, they can save between $25 to $50 million using the simplification of value-add technology that basically we're offering, using their preferences. What's even more interesting that usually the public-private partnership, they commit themselves to a 25-year maintenance and operation responsibilities. So typically a hospital, according to BOMA, Building Owners Managers Association of America, the factor would be 3.0. It means if it costs $1 billion to build, it will cost $3 billion to maintain and operate a conventional building. With our solution, we basically can save between $800 million to $1 billion over 25 years.
I think we have time for about one last question. And by the way, if folks do still want to see a diagram or something, is there something on the website they can check out? And that's
yeah, anybody that wants, I'll just type in my email.
That'll work. And I'll make sure that gets shared on the wider chat too. And
okay, I just typed in.
Cool.
Hopefully, anybody that it's in a, I put it in the participants.
Yeah, I will make sure that gets shared for everybody, but I think everybody can see that. Great, very good. Last question, if we could do this real quick, we've got 1 minute. Can the Termobuild mass floors with passive radiant heat and cooling be paired with technology like continuously insulated concrete block walls to achieve net zero energy ready buildings as a cost neutral option?
Yeah, oh yes, of course. You see, thermal energy storage, it's a value add solution. You see right now the concrete, I see this particular combination of walls and the concrete flooring can definitely move the needle. It would cost less, especially if we're talking, say, I presume it would be horizontal housing or community housing. If that's the case, then they could turn into a smart cities super block, a smart village super block, where the energy could be managed between different buildings. And the smaller microgrid could serve a lot bigger community.
And that's perfect timing. Jack, thanks so much for joining us, and appreciate all the good questions. And like Jack mentioned, his email address is there in the chat, and a link to the website as well for those of you who want to dig into Termobuild a little bit more deeply.
Well, thank you so much.